It's Jacob Penrod, homework 3. This is my implementation, naive Bayes. So I go through here, I load the Yelp data, I make sure that I get a good split using user fixed, and I'm setting my NDGC equal to 1 in this filter, and I'm setting my threshold equal to 3 for like or disliked. So in my implementation, I didn't really set much except for the threshold. I set that as 3. I keep a list of user feature metrics, which is a custom object I define at the bottom. I define this as a class to basically keep track of my liked and not liked. And also in the constructor method, for each user and feature, I set liked and not like equal to 1, and that approximates Laplacian smoothing so that we get so that a non mentioned feature doesn't just completely destroy our normalization function by giving divide by 0. And I do a very simple percentage of not liked and liked here, which I will use in my train. So I didn't change any of the setup. The train model is just going through the users, the items, initializing probability like to not like to 0.5, and then I check if my user feature list already has a record for that user and feature. If it doesn't, I add it. If it does, I just find it and I'm going to update it based on whether or not the value is above the threshold, then it's liked. If it's below the threshold, then it's disliked. If it's 0, then it's just a non-rating. Then I multiply the log percentage liked and log percentage disliked, and I do 1 divided by probability liked and minus not liked. And this is my normalization function, and this is overridden for each user and feature. So every time there's a liked and not liked, it'll get updated. And the one we end up with will be the correct one. My predict, I basically just loop through the list, find that user and item that's given, and then pull the normalized value and return that for the rankings. So to compare that to, I used Slim Recommender for content, or not for content, for collaborative filtering. Naive Bayes was for content filtering. So here I didn't change anything except for I updated all my setup, train, and predict to public so that I could run a hybrid recommender. And for Slim, I just tweaked the L1 and L2 regulation numbers, and I found that a really low L1 and a really high L2 gave the best features. When I did a hybrid, my hybrid recommendation is really simple. I just instantiated a recommender for each class, gave them context, and I have a weight that I defined in my config file, and I call setup, I call train, I call predict, and then I multiply the values times the weights. And for naive Bayes by itself, I was able to get about 0.08. For Slim, I was able to get about 0.04, and for the hybrid, I was able to get about 0.04. A little bit better, 0.042 or so. And yeah, and that's homework 3.